Resistors are in series. Resistors are in series. Resistors are in series. I will discuss that. Let me draw a small diagram, then only you can understand that. There are problems, plenty of problems based on this theory. And so we have a battery, plus terminal, minus terminal. Okay, suppose the battery voltage is V. This derivation is there in our syllabus. I will discuss one derivation. That derivation is there in our syllabus. I have a battery, some wire is there having some resistance. There is a wire connected having some resistance. Resistance means the more resistance of the wire means the current will find it very difficult to move. That's all. The more resistance means, the more resistance of a wire means the less current. The current find it very difficult to move. Let it be a resistor. Resistor means having some resistance. I will discuss. Listen carefully. Again, we have another resistor. We have another resistor. 1 minute. We have another resistor. Just a minute. We have 3 or more resistors are there. There are 3 or more resistors are there. Resistor means it is a wire which offer resistance to the current. Resistor means what? It is simply a wire which offer resistance to the current. For example, if you put something like not a copper wire, if you put something like another wire like plastic or paper like that, the current will find it very difficult to flow through the paper, right? Not like a copper wire. The current will find it very difficult to flow through a paper or some other material. So it offers some resistance. Suppose this wire has the resistance R1, this one has resistance R2, R3, etc. Okay, 3 or more resistors are connected in series. This type of connection is said to be series. Okay. The battery voltage is V. The battery voltage is V. So listen, there will be some current. There will be some current, say I, will be flowing through the resistors. There will be some current flowing through the resistors. And remember, the potential difference between each resistors can be measured by using some device. The potential difference across each resistors can be measured using a device. Let it be V1. Potential difference is what? I mean the energy. The potential difference between 2 points means how much work is done to move a charge from this point to this point. How much work is done by the source? How much work is done by the source to move a unit charge from this point to this point? Just like a water flow. You think about the water flow. Listen. The water flow, there are 3 pipes. There are 3 narrow pipes offering some resistance. There are 3 narrow pipes offering some resistance to the flow of the water. The potential difference means that how much work is done by this motor or this device to transfer a unit quantity of water from this terminal to this terminal. To move a unit quantity of water from this terminal to this terminal, the source is doing some work. That is V1. V1 is the work done by the source to move a unit charge from this point to this point. V1. The current through the resistor is I. And remember, the potential difference between across R2 is V2. So listen, V2 is the potential difference. V2 is the potential difference between this point and this point, meaning that how much work done by the battery to move a unit positive charge from this terminal to this terminal. Some work is done, right? That work is V2. The current is same. In series, the current remains the same. Through each resistors, the current will be same. V3 is the potential difference across R3. The work done to transfer a unit charge from this point to this point, that is V3. Some important points you have to memorize without any proof. The entire proof is there in our syllabus. So listen. All of you listen. So V1 is the energy required to move. Let me talk about water flow. Okay, let me talk about water flow. V1 is the energy required for the water to move from this point to this point. Let me say like that, then you can understand that. V1 is the energy required by the water to move from this point to this point. V2 is the energy required to move the water from this point to this point, and V3 is the energy required for the water to move from this point to this point. The total energy supplied by the source, motor, think like a motor. This motor pump the water. The total energy supplied by the battery, or motor. The total energy supplied by the motor is V. That V equal to V1 plus V2 plus V3. Understood? This energy, understood? The energy required to move this path plus energy required to move this path plus energy required to move this path. That will be the total energy supplied by the motor. So the total energy supplied by the motor V equal to energy required to cross R1 plus energy required to cross R2 plus energy required to cross R3. There is no exact proof mentioned in the textbook. So you think about the water flow. You need to think about the water flow. Then only you will get some clarity about this. V equal to V1 plus V2 plus V3. Equation number 1. Now, so V equal to V1 plus V2 plus V3. The exact proof of this one is not there. But you think about that. Think about the water flow. The water will cross this entire pipe. The water need V1 energy plus V2 energy plus V3 energy to cross the entire things. So the total energy supplied by the battery V equal to this energy plus energy required to cross this one plus energy required to cross this one. Now listen, in the previous class we studied that. In the previous class we studied that. This is about the previous class. This is about what? Previous class, sorry. This is about the previous class. This thing. Concentrate on only on this thing. Ohm's law can be applied here. Ohm's law means the potential difference between 2 points. Ohm's law says that the potential difference between 2 points, V1 is equal to the current into the resistance. Potential difference between 2 points, or energy required to cross the pipe or conductor. Energy required to cross the pipe is equal to the current into resistance, I into R1. That is Ohm's law, we studied already. If you have, so V1 equal to IR1 and V2. Focus on this thing alone. The potential difference across between these two terminals, or energy required to cross from this point to this point, V2 equal to current into resistance. That is Ohm's law, we studied that. Similarly V3, Ohm's law says that V3 equal to the potential difference between these 2 points, V3 equal to the current into the resistance of the path. We studied that potential difference between 2 points is equal to current into the resistance. That we studied in the earlier classes, which is actually Ohm's law. Okay. Now the first equation. First equation says that V equal to, what is V? V is the battery voltage. What is V? V is the battery voltage. V1, what is V1? V1 is IR1, understood? V equal to IR1. And what is V2? V2 equal to IR2. And what is V3? V3 is IR3. This derivation is very, very important. It is there in our syllabus. It is there in our syllabus. So V equal to, initially I told you the total energy equal to energy required to jump each of these resistors. Let me say like that, okay? Energy required to jump this path plus this path plus this path. That will be the total energy. So V equal to IR1 plus IR2 plus IR3. V equal to, listen, you can see that I is common in all the terms. I is common in all the terms. I is taken out. R1 plus R2 plus R3. You see, you know that I is common in all the terms. You can take I outside. So it's a very simple step, right? I is taken out. Now let me do one thing. I is taken to the left hand side. Is there any issue that? No issue that I is taken to the left hand side. So I got V by I equal to R1 plus R2 plus R3. What you can say about V by I? V is the battery voltage. What is V? V is the battery voltage. What is I? I is the current originating from the battery. V by I will be considered as the total resistance of the entire path. Understood? V by I, because the Ohm's law says like that, clear. Ohm's law says that V by I is the resistance faced by total resistance. Understood? Ohm's law says that voltage of the battery by current originating from the battery. Voltage by current is the total resistance faced by the battery. Total resistance faced by the battery. That is V by I. We studied it is the actually Ohm's law. So V by I is, we can consider V by I as the total resistance, or we can say that effective resistance, or if in short form, R effective means effective resistance or total resistance. Effective resistance or total resistance. V by I is R, which is actually Ohm's law. The total resistance equal to R1 plus R2 plus R3. So this derivation is very, very important. If two or more resistors are connected in series, it can be bulb actually, okay? It can be bulb. If I connect more bulb in series, the total resistance offered by the bulb will be R1 plus, R2 plus, R3 plus, etc. etc. The more bulb connected in series, the resistance value will be increased. R1 plus, R2 plus, R3 plus, etc. The total resistance will be increased. So let me generalize. So in general, R1, R2, R3, etc. are in series like that. Series means they connected like this. The total resistance, effective resistance, is obtained by adding each resistances. Simply adding all the resistance together, we will get the total resistance. Total resistance means V by I, the battery voltage by battery current. This is considered as the total resistance. So each individual resistance values to be added, we will get the total resistance. Okay, look at this question. I will read it. This symbol means a resistor. Okay, don't worry about this symbol. I mean, it is a conductor having some resistance. Clear? It's a conductor having certain resistance. We do not like this. Okay, I will explain the symbols for each one. Okay, let me discuss this problem. An electric lamp. What is this? This is the electric lamp whose resistance is 20 ohm. So this lamp means, understood, there is a small wires, understood, clear. Twisted wires are there in the inside the lamp. If you look at the lamp, there is a lot of twisted wires are there. That twisted wires having certain resistance. The current find it a little bit difficulty. The current find it a little bit difficulty to move through the twisted wires. So this bulb having certain resistance given in the problem 20 ohm. It's mentioned electric lamp having resistance 20 ohm, and a conductor. Conductor means a wire. Okay, having resistance 4 ohm. Battery 6 volt. Can you see that? 6 volt battery is there. Battery symbol you studied in the lower classes, but I will revise the symbol again. Let me discuss the problem first. This is the battery. 6 volt. Calculate the total resistance of the circuit. And don't worry about this symbol. This K means that it is a switch. Clear? If the switch is pressed, the current will flow through that. Understood? K means it is a switch or key. Switch or key. This A means it is the device for measuring current. We don't use this one. Okay? To solve this question, we don't use this one. A. This one is just a device to measure the current. So the battery is there, some current is flowing through this entire thing. 4 ohm resistance, another resistance 20 ohm. Clear? I will give you questions. You please listen carefully. The total resistance. Listen, look at this. This formula you have to memorize. There are so many resistors connected in series. The total resistance faced by the current will be R1 plus, R2 plus, R3 plus, etc. So here there are two resistors, this one and this one, no other resistors. So the effective resistance or total resistance is also called effective resistance. Only two resistors, R1 and R2. Let me denote by R1 and R2. You have to write the all important steps. 4 plus 20. The unit is ohm. Okay, this Greek symbol is used. First part is very simple question. A part is over. The effective resistor. Now I am going to discuss the second question. The current through the circuit. The current through the circuit is very simple. The circuit current or battery current is our question. Battery current means it is the current originating from the battery. That is our question. The current originating from the battery. That is the second question. Remember, the current originating from the battery, as per Ohm's law, battery voltage by effective resistance. I suggest you better memorize this formula so that you will not have any confusion. This is actually Ohm's law, that it's not a new thing. The battery current, if you want to find out the battery current, what should I do? To find the battery current means current originating from the battery. The battery current, let me write here. So this is battery current. Current originating from the battery. This way is to consider as the battery voltage. The R value should be the total resistance. I equal to V by R. Denominator should be the effective or total resistance. Clear? So I equal to V by R we have already studied. It is actually Ohm's law. So battery current is given by battery voltage divided by the effective resistance, total resistance. So I am going to answer B part. So the battery current I equal to battery voltage is what? Battery voltage is 6 volt. Clear? Battery voltage is 6 volt divided by the effective resistance. It is 24 ohm. It is a solved example given in textbook. 6 by 24 reducing. That's very simple step, right? 6 is cancelled. You have to do the division. Okay, it is important. In physics it is important. You have to do the division. 1 by 4, you know how to do the division. The current has the unit ampere. We studied in the first class. The unit of current is 0.25 ampere. I mean ampere. Then C part I am going to discuss. C part. What is C part? The potential difference across the lamp and conductor. Potential difference, I have already discussed that. Potential difference means between these two terminals of the resistor there is some potential difference, V1. I have explained some 5 or 10 times. I explained V1 is the energy required. V1 is nothing but it is energy required to move the unit charge from this point to the other point. I mean, or water flow. In order to water to move from this point to this point, it needs some energy, right? If the water do not have any energy, it cannot cross it. So in order to cross it, the water should have some energy. That energy is V1, understood? So in the same way, in order to cross the current from this point to that point, the current should have some energy. That energy is V1. Similarly, V2 is required. How much energy is required to cross this one? V1 and V2 both are required. Remember, both resistors carry the same battery current. Understood? This current does not split. The same current will be passing through the every components. If there is some splitting happens, okay, some current take this path, some current take this path, we can say like that. But there is no splitting of the path. So whatever current originates from the battery, the same current will be passing through every component. So this one I have already discussed. This is simply Ohm's law. V equal to IR. That part also you have to memorize. V equal to what? Energy is equal to what? V equal to IR. So V1 is equal to the current into the resistance. Current into resistance is the voltage. Current into resistance. So voltage is equal to current into resistance. V1 and V2 we have to find out. V1 and V2 we have to find out. I have already found. I have already found 0.25. I have already found 0.25. R1 is 4 ohm, right? R1 is 4 ohm. 4 into 0.25, 1. Voltage has the unit volt. 1 volt. 1 volt energy is required for the current to cross this. Understood? 1 voltage energy is required. And the another one is voltage across. V2 is also I want. Voltage is equal to potential difference equal to current into resistance. Please memorize that. Potential difference V equal to current into resistance. Current is same current, same battery current is passing through this. 0.25. 0.25 into R2. R2 is what? 20, correct? I mean multiplication part I don't want to discuss. 20 by 4. 5 volt. So I have answered everything. Please solve this question. Write your solution on your notebook. Take the photo. Send to me through WhatsApp right now in the class. Okay? If you please listen. So I explained the resistors in series. Let me discuss next one. Resistors in parallel. Derivation I am discussing. resistors in parallel. These derivations are very, very important. You must resistors in parallel. The parallel means, listen, the parallel, I will discuss that. Resistor means it is a wire offering resistance to the current. The current find it a little bit difficulty to cross it. Understood? Again and again I am discussing that. We have 3 or more resistors. Okay, they are, first of all, they placed parallel. First of all, they have placed parallel. Resistance is also denoted by this symbol. Okay, but let me use the color to make you understand. So the parallel means I have 3 separate wires, each of them offer resistance to the current. Clear? What I am doing is, the left points are connected together. The left sides of each resistor is connected together. There is a common point, and the right terminal of each resistor is connected together. The right terminals of each resistor is connected together. We have a common point here, and this one is connected across the battery. There is a battery here, there is a battery here. This is connected like this. The battery voltage is, let it be V. Each of them having resistor R1, R2, R3, R4, etc. This type of connection is said to be parallel connection. Okay, if the question contains explain parallel connection, derive the formula of current, derive the formula of effective resistance, you have to draw the diagram. Either you can mark like this. Okay, resistor can be denoted by like this also. This symbol is also used. Okay, so what I am saying is, suppose I am going to derive the total resistance. I am going to derive the total resistance. Suppose the battery current is I. The battery current is I. Just like a water flow. Just like a water flow. Let I be the flow of the water. All of you please listen. Let I be the flow of the water. When this water enter this junction, there is a pipe here. Through this pipe, I quantity of water is flowing. And this water enter this junction. There are 3 separate pipes. There are 3 separate pipes. So some part of the water, I mean current, will take this path. Some will take this path, and some will this path. It's very simple. Think like that. You have to think about the water flow. Think about the water flow. The water is originating from this motor. There is a motor there. The water is originating from this motor. Water is entering this junction. Suppose I quantity of water is entering this junction. Some water quantity, say I1, take this path. Some take this path, some take this path. Depending on the resistor, the water the values of I1, I2, I3 may be different. But I can say that the total quantity of water entering the junction is equal to the total quantity, let me say like water, actually it is a current. The total quantity of water entering the junction is equal to the total water leaving the junction. Total quantity of water entering the junction equal to total quantity of water leaving the junction. I1 plus I2 plus I3. This must be the first step. This must be the beginning. The total battery current is equal to individual currents, sum of the currents through each resistors. Okay, I equal to I1 plus I2 plus I3. Now what is this I actually? What is this I actually? I is the battery current. Understood? Let me explain once again. This I is the battery current. Isn't it? Capital letter I is the current originating from the battery. I told you to memorize the battery current formula. It is actually derived from the obtained from the Ohm's law. The battery current is equal to battery voltage divided by the total resistance faced by the battery. Clear? The battery current I is equal to what? Battery voltage divided by the total resistance. So that formula I am going to use. The battery current is the left hand side, right? The battery current equal to battery voltage V divided by the resistance, the total resistance of the entire system, total resistance. I1. And what is this I1? That part I will discuss. Listen carefully. I1. What is the potential difference across R1? What is the potential difference across R1? This is the left side of R1, isn't it? This point highlighted one is the left side of R1. This is directly going to which point? Positive terminal of the battery, isn't it correct? Through this green colored path there is no resistance, understood? Through this green colored path there is no resistance. So what I can say that the left point of R1 directly connected to the battery. I can say like that. The left side of R1 directly connected to battery. And what about the right terminal? Right terminal of R1, look at the path. Is it directly going to the battery, negative terminal of the battery? Yes. Through this highlighted path there is no resistance. It is an aluminum wire. Aluminum wire does not have any resistance. So my conclusion is R1 is directly connected to the battery. Understood? R1 is directly connected to the battery. R1, left side of R1 is going to the one terminal of the battery. Right side point is directly going to the other terminal of the battery. So the battery voltage, the potential difference across R1 is nothing but the battery voltage. The entire battery voltage will be appeared across the endpoints of R1, because this entire R1 is connected across battery. So battery voltage is V. So the same voltage will be appeared across the endpoints of R1. So the potential difference across R1 is V. Then next, let me remove this highlighted path. 1 minute. Then in the same way, I don't want to highlight it. You understood the logic. The left side of R2, this point, right? The left side of R2, where is it going? The left side of R2 is directly going to the positive terminal. The right side of R2 also directly going to the other terminal. So potential difference across R2 is also V itself. Similarly, left side of R3 directly going to one terminal, right side also directly going to the other terminal V. So you have to write it as a note. It's very, very important. Let me write it as a note. This is a very important fact. In parallel connection, the connection like this, the voltages, potential difference or voltages across each resistors are equal. It's a very important fact. You have to memorize that. V. The potential difference across each resistors will be V. Now listen, we have already studied. Let me write here in the right side. The potential difference V equal to IR. We studied that. The potential difference V equal to what? I into R. So the potential difference across the first resistor V equal to I1 into R1. I1 into R1. That is Ohm's law, right? The potential difference across the resistor is equal to current into resistance. V equal to I1 into R1. V equal to current into resistance. Similarly, the potential difference across the second resistor. The potential difference across the second resistor also current into resistance. Current into resistance means I2 into R2. All these steps are required. And potential difference across the third resistor, V, equal to current into resistance. Current into resistance will be the potential difference. Some smaller steps I want to skip. From here, I1, can I say that I1 is V by R1? Is there any mistake? No mistake. I1 can be written as V by R1. R1 can be taken to left. So I1 is V by R1. So here I1 is there. I1 is there. V by R1. I2 is there. I2 is V by R2. I2 is V by R2. And what is I3? I3 is V by R3. Or V by R effective. In the right side, you can see that V is common. In the right side, you can see that V is common. You can take V outside. If there is any common term, you take it outside. If you take V outside, 1 by R1 plus 1 by R2 plus 1 by R3. You can, so V is common. You can cancel V both sides. You can cancel both sides. Let me generalize this. If R1, R2, R3 are in parallel connection, 1 by R1, let me write the general equation right now, okay? If there are more resistors like R4, R5, etc., let me generalize this, okay? So our conclusion is, if R1, R2, R3, etc. are in parallel connection will be like this. The effective resistance is given by using this formula. Effective means total resistance of the entire system. 1 by R effective equal to 1 by R1 plus 1 by R2 plus 1 by R3, etc. This formula you have to memorize.